Greetings again. I have received a lot of feedback that people are getting tripped up on the Khan Academy and getting a little confused as to how it relates to what we did before. So I'm going to work through two of your actual Khan Academy questions. Maybe you've seen these ones, maybe you haven't. There's a fairly large pool of these questions, so we'll see. So this question, copied directly from Khan Academy, is an example of where essentially all the Khan Academy questions are where you'd want to put the force so that the whole thing maintains an equilibrium. Equilibrium is a word that we may not have necessarily gone over, but equilibrium means no rotation, total balance. Think of the word equal, all things canceling out. So what you want to do is examine this in terms of clockwise and counterclockwise forces. So currently, as it stands, there is well, again, look at the arrow and think of the circle. Look at the direction and think of the circle. There is a clockwise force acting on this system. There is a clockwise torque. In order to have an equilibrium, all the clockwise and counterclockwise forces should cancel. So if this is a clockwise force, we're going to need a counterclockwise force. So it says we need to add another downward force to cancel the clockwise force that's right here. So we have a force that's a 4F. So this is what I'm going to do. Oh, that was a straight line. Nice. So again, equal it out. Here's the fulcrum. On the right side, okay, on the right side, what we have is we have a clockwise force that is a distance of 1, 2, 3, 4. I'm just going to call that 4D. Another way of writing that out is if I multiply all that together, I could say it's called 4FD. Is my clockwise force, okay? That's going this way. So if I have to put a down arrow here, I have to put a down arrow either x1, x2, x3, or x4. I know that if it's going to be a down arrow to create a counterclockwise force, it has to either be x1 or x2. x3 and x4 would not provide a counterclockwise force. Therefore, you could not achieve equilibrium with those two. So it's got to be either x1 or x2. So let's find out which one it is. So I need it to equal 4. So if I have a 4F already, because it says it's 4F, the only way it could be equal is if it's it could either be 1D or it could be 2D. Well, if it's 2D, this would become 8FD, and then it wouldn't be equal. It would have to be just one distance away. Think about FD equals FD. So it's got to be one distance away so that the whole system cancels out. So I have 4FD equals 4FD counterclockwise equals 4FD clockwise, and thus the whole thing cancels out. So the 4F would have to go here, 4F, and this counterclockwise motion would cancel, because it's a much bigger force, would cancel the smaller force at a greater distance of clockwise motion. So this would have to be the answer. So again, the only thing is that the balance has to occur where you have the same torque on both sides. The counterclockwise and clockwise forces cancel out. So this one wasn't so bad. This was kind of like what the levers we did last week, where if you would have 4 times the force, it would be 1/4 the distance. What I think is throwing people is this question right here, where you go ahead and have to provide the upward force. Now, it works the same way as we just did. So now what we have to do is this is essentially the exact same question, but the only difference is that instead of it being a downward force, it's an upward force. So I want you to think about it. So where are we going to put a 4F upward force to go ahead and create an equilibrium to get this to balance out? But I want you to think about it. This force is still here. This force is still in counterclockwise rotation. So if I provide an upward force, if I put an upward force here, this would also be clockwise rotation. This would also be clockwise rotation. So putting it at these spots couldn't cancel this clockwise rotation from all the way over here. But if I put upward here, or I put an upward force here, these would be counterclockwise rotations. These could potentially cancel the clockwise rotation from here. You need a clockwise rotation and a counterclockwise rotation in order to balance out. So because it's up, it's going to balance. So if this is 4F, if this is F, and the distance is 1, 2, 3, 4, and this is 4 distance, and then now we will have to go ahead and put a force of 4. In order to have it cancel, we're going to use the exact same logic. We have the 4 out front. We only need a 1 distance here, meaning that this spot right here would have to be the answer at the spot of x3, because what we're essentially saying is it's 4F times 1d. Will that equal and cancel the F times 4d? Because all we're doing is we're just counting the distances on that ruler. That's where the 1d and the 4d come from. And therefore you have 4FD and 4FD. These forces are equal and opposite. This one is counterclockwise, this one is clockwise, so therefore they cancel and you have equilibrium. So that's how you do this. Just be mindful, are the forces clockwise or counterclockwise? So again, as you go through this, make sure that you ask me questions. I'm here to help. A lot of people said the FET was easy once they found out that you could like drag the weights and masses around. Play around with it. It's fairly easy. A lot of people have already had a lot of success with that. And don't let the Khan Academy throw you. Of course, they're going to make it seem a little bit more complicated than it needs to be, but there's nothing here you can't do. Just think, as long as the clockwise forces are canceled with the counterclockwise forces, you are balanced. You are at equilibrium. Best of luck, and I will see you guys on, well, I don't know when I'll see you, but I'll talk to you again on Wednesday.